I'm Misbah with Tektronix, and today I'm here with our new 7 Series oscilloscope equipped with our signal integrity modeling software. With SIM, you can do embedding, de-embedding, equalization, or a combination of the three. Here I have an AWG outputting a 16 gigabit PRBS signal going through 17 inches of PCB trace and then into channel 1 of my oscilloscope. I have another 16 gigabit PRBS signal going through 9 inches of trace and into channel 3 of my oscilloscope. Here I've done CTLE receiver equalization for the signal propagating through 17 inches of trace to open up that eye diagram. And below it, I've done de-embed of the cable, the 9-inch PCB trace, and then the other cable bringing my signal from the PCB board into my oscilloscope. The good thing about SIM is that you can render as many models as you want with unlimited number of test points, giving you great visibility across the entire signal path. Let's take a look at the receiver equalization workflow. So I'll go into the SIM configuration menu for receiver equalization. Here under workflow, you can choose between de-embed, embed, receiver equalization, which is this example, or you can do the advanced workflow, which is a combination of all three, so you can model our alternative signal paths. So for receiver equalization, we have CTLE selected, but you could also select FFE or DFE. You can also add an unlimited number of virtual test points simply by clicking Add Test Point and dragging it wherever you want that test point to be along your signal path. But for this example, we'll stick with CTLE. So I'll deselect these. And so now we have CTLE and a test point that's going to show our post-CTLE waveform on Math 1. To configure your CTLE, you can double tap it. This is where you enter your zeros and poles. Once you have that configured, you can calculate SIM. Okay. And now we have our original waveform on channel 1, as well as the post-CTLE waveform on Math 1. And I've rendered eye diagrams for both of those here and here to show you an easy side-by-side comparison. Now let's take a look at our de-embedding workflow. So let's open up the configuration window for our second SIM. For this workflow, we've selected de-embedding. And our physical model contains all of the elements along our signal path. So we have our DUT source, which is our AWG, cable, PCB trace, cable, and then to the scope. To add additional measurement blocks, all you have to do is click Add Block, click and drag anywhere along the signal path. To configure each of those elements, you just double tap and upload the S parameter file. Once you've done so, you can click Plot, check out your S parameter plots, and if anything, if it looks like you've accidentally mapped the ports incorrectly, you can change your port mapping directly in the user interface. So in this example, we're de-embedding the cable, PCB trace cable, and so then our simulated model just becomes the DUT source, and our virtual test point is right at the output of that DUT source. And we'll see that signal on Math 2. So let's take a look. So here we have the original waveform on channel 3 and the de-embedded waveform on Math 2. And I've rendered eye diagrams for each of those for easy side-by-side compare. The good thing about SIM is that you can render as many models as you want with unlimited number of test points, giving you great visibility across the entire signal path.